Welcome to Science Manthan. Today, we're jumping right into a brand new explainer about an invisible, almost magical world that literally surrounds us every single day. We're going to be talking about the totally fascinating mechanics of magnets. Look around your house or, your classroom. Have you ever wondered why that refrigerator door just kind of clicks shut on its own right at the last second? Or why a whiteboard duster just slaps effortlessly onto the board and stays there, completely defying gravity, right? These are everyday mysteries, but they are driven by a hidden force sitting right in front of us. It's a force so reliable, we absolutely take it for granted, but the science behind how it actually works is just incredible. Okay, let's dive into this. Here is our roadmap for today. We'll be looking at 1. The magic of magnets, 2. From rocks to factories, 3. Shapes and sizes, 4. What sticks and why, and 5. The power of poles. All right, starting with Section 1, the magic of magnets, understanding the invisible pole. So it all begins with this core definition. A magnet is a material that produces an invisible magnetic force, enabling it to attract certain metals without any direct contact. I mean, just think about that for a second. It's an invisible force reaching out across thin air and pulling an object without actually touching it. It's literally that lack of physical contact that creates the everyday magic we see. Moving right along to Section 2, from rocks to factories, a brief history of magnetism. This is such a fascinating mini-story of human innovation. Thousands of years ago, ancient travelers stumbled upon these natural magnetic rocks called lodestones. Hundreds of years ago, ancient sailors took this discovery a massive step further. They actually invented the magnetic compass for navigation because they realized a suspended lodestone always points the same way. Fast forward to present day, and we've got massive factories manufacturing incredibly strong, super-specific magnets for our modern tech. We literally went from finding magic rocks in the dirt to marvels of modern engineering. And this brilliantly illustrates the massive jump we've made. On one side, we have natural magnets, like those ancient lodestones, which are just naturally occurring rocks rich in magnetite. But on the flip side, we have artificial magnets. Humans manufacture these from iron, steel, or rare earth materials. This is a huge leap because our artificial magnets are way stronger, totally durable, and we can tailor them for exactly what we need today. Which brings us to Section 3, shapes and sizes, tools for every job. Because artificial magnets can be molded, they come in a bunch of different shapes, each designed specifically for everyday uses. You've got your classic bar magnet, then the horseshoe or U-shaped magnet. Curving it like that actually keeps the two ends close together to create an extra strong magnetic effect. We've also got ring magnets, disc magnets, and cylindrical magnets. Basically, every shape is a very specific tool for a very specific job. All right, Section 4, what sticks and why? The secret of the domains. Have you ever wondered why a magnet aggressively grabs an iron nail but completely ignores a wooden pencil? Well, materials fall into two buckets. First, magnetic materials. Things like iron, nickel, cobalt, and certain metallic alloys. These get attracted to magnets. Then, non-magnetic materials. Wood, plastic, glass, rubber, paper, cloth, and even metals like aluminum. These are totally unaffected. It's super important to remember that not all metals are magnetic. Only specific ones make the cut. Now, what's really interesting about this slide is the secret microscopic mechanics behind it all. It is all about magnetic domains. Inside magnetic objects, there are these tiny internal regions called domains. Normally, it's total chaos. They point everywhere. But bringing a magnet nearby forces these domains to instantly align in the exact same direction, causing attraction. It's kind of like a chaotic crowd suddenly turning to march in perfect unison. And this invisible domain alignment, it's happening all around you right now. Just look at this everyday magnetic magic. It's in the speakers and earphones you use, electric bells, the strips on the back of your credit cards, inside your mobile phone components, and of course, magnetic toys and cupboard locks. Literally none of these modern conveniences work without those tiny domains lining up. Which leads us to our final and frankly most mind-bending part of the explainer, Section 5, the power of poles. The most fascinating rule of magnetism. First step, we need to clearly define magnetic poles. These are the two specific ends of a magnet, the North Pole and the South Pole, where the magnetic force is at its absolute strongest.
Engineers specifically design magnets to place the strongest points exactly where the force is needed for whatever they are building.
So the crucial point is that this invisible force varies wildly across a single magnet. Magnetic force is maximum at the poles and weakest near the middle of the magnet. It's not just an even bubble of force. The absolute extreme ends do all the heavy pulling, while the center is actually surprisingly weak.
Let's move to and see how this builds into the most incredible rule of all. Step 1. Cut a magnet into 2 pieces. Step 2. Notice each piece instantly becomes a complete, brand new magnet with its very own north and south poles. You don't just get a north piece and a south piece. Step 3. Repeat dividing it. You can slice it as tiny as you want. Every tiny fragment still contains both poles. Here is a truly mind-blowing fact to wrap up. Scientists have never observed an isolated north or south pole. You can never have just one. No matter how small you cut it, the universe demands that both poles exist together. From the everyday mystery of a closing fridge door to the unbreakable microscopic laws of nature, we've covered a lot today. Like, subscribe, and share for such more science-related videos. Also, drop your comments and queries in the comment section. We will catch you in next one.